Find the largest rectangle, that is the rectangle with largest area, that fits inside the graph of the parabola y equals x squared below the line y equals 3 with the top side of the rectangle on the horizontal line y equals 3. So I've given you a picture to explain. This is the line y equals 3. Okay, so I've drawn one such rectangle. It's not necessarily the one with the biggest area. There are lots of rectangles I could draw that satisfy this. So if I put the top on here, I could draw this rectangle instead of the one drawn in the picture. But the question is, which rectangle will maximize area? I could draw this really long and skinny one. So the one that was drawn for us is just a random one to help us visualize what this thing looks like. So what's helpful is to say, well, I drew this at a random location, so I'm going to call the x coordinate just x instead of a specific number. We'll call it x. And this one would be negative x because x squared is symmetric about the y-axis, which means this point is x comma, it's on the graph of y equals x squared, so it's x comma x squared. And this one would be negative x comma x squared. And then this point is x comma 3. And this point is negative x comma 3. To find the area of this rectangle, I just need to know the length and the width, or the base and the height. So if I want to find, if I would like to know this distance, well, I know that the distance from here, from the center over to here is x, and from the center over to here is also x, so this whole thing is 2x. And then if I want to find this vertical distance, I'm just going to look at the y-coordinates. So I'm going to do the y-coordinate on the top minus the y-coordinate on the bottom to find this distance, 3 minus x squared. So the area of the rectangle I drew is 2x times 3 minus x squared. We distribute the 2x and I get 6x minus 2x cubed. And this is what I want to maximize. Okay, and we throw it in GeoGebra, and it turns out that the maximum point is at 1, 4. And this is an x value, and 4 is an area, because what I'm graphing is this function. So the inputs are x, which represents this x, and the outputs are areas. So that's the area of the rectangle that I put it inside there. Okay, so they asked for find the largest rectangle. So the largest rectangle happens when x is 1, which means that this whole distance is 2. And then if x is 1, then x squared is also 1. So this distance here is also 2. So the largest rectangle is 2 by 2.